Hey everybody, your Friendly Math Tutor here with video 2 of our SAT one-sheet breakdown series. So the PDF files for both the one-sheet and the examples that I'll go through for today's part of it are linked below, and make sure you subscribe and check out our TikTok, Instagram, and Facebook where we have more content related to this SAT one-sheet. All right, so let's dive in. All right, so here we are on our one sheet, and last video we did strategy, so make sure to check that one out. And today we're going to go down to common problem types, and we're going to specifically look at the top three here. In this video we're going to look at linear functions, quadratic functions, and linear systems. So let's start with linear functions here. So this is everything that's in linear functions, and let's start with y equals mx plus b. So we're going to do two examples for this one, and if you look at y equals mx plus b, basically what we have is, oh, this one was supposed to have an arrow. All right, so m, different things that could represent m are slope, rate of change, increase, or decrease. And different words we would look for b is the y-intercept, the value of x when the value of x is 0, the initial value, or possibly starting value. And here's our slope formula, and that's the if we want to know the units of slope, it's the units of y over the units of x. So let's see how we can use that information in our first example. So this equation above, notice that this is y equals mx plus b. It's flipped, but it's still in different variables, but it's still y equals mx plus b. And they say, what is the increase in weight of the tire in pounds for every second the pump is used? Well, that is a slope concept. So let's look at it like this. So here the slope is 0.4 because it's the coefficient of our variable. And we could think of that as over 1. So this is what I mean by the units of y over the units of x. So our y is like w, and w is in pounds. And our s is like the x, and the units of s is seconds. So that means this is 0.4 pounds per second. So when they say what is the increase in the weight of the tire in pounds for every second, that's literally just asking the slope. So the answer is 0.4. So 0.4 pounds per second is what this represents. All right. Okay, so let's take a look at another example. And so let me just put this in again. There was supposed to be an arrow here and here. All right, so now we have another problem, which is this is one we can use from the first video. We could use a strategy called skimming the text. So we do know we have this slope-intercept form equation, and then we can go right to the question. Which of the following could be the meaning of the number 2? So the number 2 is the y-intercept because it's b. So we're looking for something that represents the value of when the value of x is 0. Well, the x is n, and n is the number of calculators. So we're looking for something that has 0 calculators in it. Well, the weight of each calculator, that has nothing to do with 0 calculators. The minimum number of calculators, that doesn't really make sense. And the average weight, so that doesn't really make any sense. What ends up making sense is A, the weight of the box used in the shipment, because the box, is the box and the calculator. So if there's a box with no calculators, then the weight of the box is when there are 0 calculators. All right. So again, the y-intercept we can just figure out if we know that it's, or like what it means, if we just know that it's the value when the x is 0, figure out what variable represents the x, what that means, so in this case calculators. So again, we have a box with 0 calculators in it, so that is the weight of the box. Okay. So now, let's head to the next type of problem. So the next type of problem is going to have us This is a standard form, and the slope in standard form is just negative a over b. So let's see how we could use that. All right, so if we can know that this is the slope, then we don't have to spend time rearranging this. So we have line L passes through the origin and is perpendicular to line 3x plus y equals c, where c is a constant. If the two lines intersect at point k and k minus 4, what is the value of k? So what I want to do is I want to find the equation of the line that passes through the origin and is perpendicular to this line. Well, perpendicular to this line, I want to find the slope of that line. So the slope of this line is negative a over b. So that's negative 3 over 1. And then I want the slope of the line perpendicular to that for this line, because it's perpendicular to it. So that is going to be 1 over 3. The slope of a perpendicular line is the negative reciprocal. And then I know the equation of the line is simply just y equals 1/3 x, because its y-intercept is 0. So it's just 1/3 x plus 0. All right, so again, just to recap, the slope of this line is negative 3 over 1 because I'm using this formula right here. You could rearrange it. That's not that difficult. But again, I just wanted to go over. Sometimes this can be really quick if you can just look at it this way. And then now we have the equation of our line, and it goes through the point k comma k minus 4. So now I can do k minus 4 equals 1/3 k. So I'm just substituting in k and k minus 4 for x and y. So then I can just solve this. I'll multiply everything by 3. So 3k minus 12 equals k. And then I'm going to subtract k over here to get 2k. I'm going to add 12 over here to get 12. So k equals 6, which is answer choice B. Okay, let's keep it going and take a look at the last type of problem. So when solving linear equations, if you get 0 equals 0, there's an infinite number of solutions. If you get something like 0 equals 2, there's no solution. So the way we're going to solve this problem is in the beginning, we're simply just going to solve it. So I could add 6 to both sides. So let me start with 3x minus 6 equals negative 6 plus 3x. If I add 6 to both sides, I'll just get 3x equals 3x. And if I take away 3x from both sides, I will get 0 equals 0. So 0 equals 0 means there's an infinite number of solutions, which means the equation is true for any value of x. All right, let's keep going. So that concludes our linear functions part. Now we're going to move on to quadratic functions. So the first part of quadratic functions has to do with ways to solve a quadratic equation. So to kind of talk about these, you want to try to factor it first. So if we take a look at this, x squared plus 4x plus 2, in order to factor, we would need to find numbers that multiply to 2 and add to 4. And that's not possible. I would want to use square roots when b is 0, but b is not 0, so I can't use square roots. Then I would use completing the square if a is 1, so check, and b is even, 4, so check. So instead of using the quadratic formula, it'll actually be quicker to do the completing the square method, which means I will first move the 2 over to this side to get negative 2. And now I'm going to complete the square. The way I complete the square is I add half of b times itself, so half of b squared. Half of 4 is 2, 2 squared is 4, so I'm going to add 4 to each side to complete the square. The reason I complete the square is because x squared plus 4x plus 4 factors to x plus 2 squared. It'll be a perfect square if we complete the square appropriately. Negative 2 plus 4 is 2. Then, the reason I want a perfect square is because then I can square root each side. So I get x plus 2 is equal to plus or minus root 2. That's super important that when you take the square root of each side that you have a plus or minus. And now to get the x by itself, I'm going to subtract 2 from each side. So I get negative 2 plus or minus root 2. So that is answer choice A. You would get the same thing by doing the quadratic formula. I just think it's easier when, again, A is 1 and B is even. That's why this cheat sheet kind of really like goes through each little piece to kind of give you the best way, or at least what I think is the best way to solve each problem. You could disagree with some of that, and you might just think, nah, I'd rather just do the quadratic formula. You'll still get the same answer. I think there might be a little more simplifying involved to get there, but to each their own. All right, let's go to example 2. So this is another way to solve a quadratic. All right, so this one is an example of where I would try factoring first. And when you do factor, we're going to use what's called the AC method. So I'm going to start by doing 2 times 3, which is 6. And I'm looking for factors of 6 that add up to -7. That ends up being -6 and -1. So I'm going to rewrite this as 2a squared minus 6a minus 1a plus 3 equals 0. And then I'm going to factor by grouping. So I'm going to take a 2a out of the first 2 terms. So I'm left with an a minus 3. Then I'm going to take a -1 out of the second 2 terms. So I'm also left with an a minus 3. When you get the same factor here, you know you're on the right track. So if I factor this now, it's 2a minus 1 times a minus 3 equals 0. And if I set each one of these equal to 0, I get 2a equals 1 and a equals a half. This one, if I set a minus 3 equal to 0, I'll get a equals 3. It says that a is less than 1, so I'm going to choose this answer. So the answer is 1/2. All right. So now we keep going. So our next type of problem is going to be the solutions to a quadratic, the types and the numbers of solutions. So what we have here is this b squared minus 4a part, b squared minus 4ac is called the discriminant. So in a problem like this, when they say if the equation represents a parabola is tangent to the x-axis, what's the value of k? Well, tangent to the x-axis is going to mean that it only has one real solution, which means b squared minus 4ac. So let me back up. The number of solutions to a quadratic is going to represent the number of x-intercepts it has. So if it's tangent, it's only going to cross the x-axis once. So b squared minus 4ac has to equal 0 based off of what I have over here. So b squared is, b is -10, so I get -10 squared minus 4. A is 1 and c is k. So I get 100 minus 4k equals 0. 100 equals 4k. Divide by 4. So k would have to be 25. Again, other ways you could have solved this, and if you did, that's totally fine. I just picked this as a problem just to review the types of solutions to a quadratic. If we wanted there to be 2 real solutions, we would have set the discriminant greater than 0. And if we wanted there to be no real solutions or only imaginary solutions, we would have set it less than 0. All right, let's keep moving. And now we're going to look at the constants and coefficients given by a certain form of a quadratic. So this is a question they like to ask. And what happens is if they want the y-intercept given as constants and coefficients, we would want it to be in standard form. If they want the vertex, we want it to be in vertex form. And if they want the x-intercepts, we would want it to be in intercept form. So here, this one just says we want the parabola displaying the x-intercepts as constants or coefficients. That means we want in intercept form. So get rid of a and b immediately because they're not even in intercept form. So then we look at what the intercepts are, -6 and 3. And if you look at intercept form is x minus the x-intercepts. So it's really x minus -6 and x minus 3. But x minus -6 is just x plus 6. So it's x plus 6, x minus 3 would fit this equation, and that is answer choice C. All right, so again, we get rid of a and b because that's vertex form, and they didn't want the vertex as constants or coefficients. They wanted the x-intercepts. All right, so that is it for quadratic functions. So let's move on to our last topic of linear systems. So here we have a couple different types of problems. So first we're going to look at the types of solutions to a linear system. And example 1 is going to be a type of problem where we have to come up with a value of c that would make our system have no solution. So I think no solution is when the slope is the same. So one way to do this is to also use something that we learned earlier. When something's in standard form, the slope can be thought of as negative a over b, when standard form is ax plus by equals c. So if you think about the slope of the first one is negative 3 over negative 2. And we want the slopes to be the same. So the slope of the second one is negative c over negative 7. So I'm just following this formula. This is where this formula really comes in handy. When something's in standard form, the slope is negative a over b. So if I do that for both of them and I set them equal to each other, because no solution is when they have same slope, I don't really have to worry about the different y-intercept here. I just want them to have the same slope. So if I cross multiply, I get 21 equals 2c. So 21 over 2 equals c, which is answer choice D. There is a way to get this using the elimination method, but if you just want to do it this way using slopes, that totally works. You could multiply the top by 7 and the bottom by 2, and you would also end up with the answer 21 over 2. So let's look at another way that we could look at the types of problems. So here we're going to do this a little differently because of the fact that when I figure out the slope of the second one, I'm going to get c and a d in it, and I won't be able to solve that an equation like this with two variables in it. So I'm going to take a different approach here. Since they have the same slope and same y-intercept, that means I can just make the equations, that means they're the same exact line. So what I'm going to do is I'm going to multiply the second, equation by 4. So the first equation is 5x plus 16y equals 36. And if I multiply the second equation by 4, I get 4cx plus 4dy equals 36. So in order to have the same slope, I would have to have the same coefficients here in front of x and y, because I now know I have the same y-intercept. I have the same constant on the right side. I know that's not the y-intercept, but that would lead to us having the same y-intercept. So if I have the same line, then I need 4c to equal 5, and I also need 4d to equal 16. So that means c is 5 over 4. Oops. And that means d is equal to 4. And then this one, c times d, well, 5 over 4 times 4 is 5. So the answer is 5. All right, so I took a different approach here. I just tried to make them the same line, whereas in the last one I used the slopes. So that's, again, just how I chose to attack these problems. But that's how we can figure out constants if there's either no solutions or possibly infinite solutions. All right, let's keep it moving to ways to solve a linear system. So our third example is how we're going to solve a system for x. And if it's in standard form, I would use the elimination method. And further, I would eliminate the y's since we want to find the value of x. So I'm going to eliminate the y's by multiplying the second equation by 3. So I'm going to get negative 12x. Wait, I don't know what's going on there. I'm going to erase that. I think I chose the wrong pen, so let's go back. Yeah, this one's better. So I'm going to multiply the second equation by 3. So I'm going to get negative 4x minus 15y equals negative 17. And then if I multiply the second equation by 3, I get negative 3x plus 15y equals negative 39. Now I'm going to add the equations together, and the y's are going to eliminate. I'm going to get negative 7x equals negative 56 Wait, did I do that right? Yeah, 39 and 17. Yeah, negative 56. And then I'm going to divide each side by negative 7, and I'm going to get x equals 8. And they asked for x, so that's why I eliminated the y's. If they asked for y, I would have eliminated the x's. So you really want to try to save yourself as much work as possible. So when you do the elimination method, make sure you're eliminating the variable that they don't want you to find. And finally, let's move on to our last problem. And in this one, we are going to solve a word problem that requires a system. So we got a hair shampoo, comes in regular and deluxe. A deluxe bottle, so D, contains 6 more than the regular one. So that's 6 plus R. If 4 regular and 3 deluxe contain a total of 74 ounces. So just reading it, each sentence, I can come up with the equations. Now, substitution when one variable is isolated, or easily can be. So D is isolated, all right? But how many ounces of shampoo are in a deluxe bottle? So if I substitute 4D, then that's going to give me R, but I don't want to know R, I want to know D. So I'm going to do the easily can be part and just say that D minus 6 equals R, and then substitute that for R. So I'm going to have 4 times D minus 6 plus 3D. And I'm substituting this way because I want to solve for D, and they ask for the deluxe bottle. I could solve for R and then plug back in, but a lot of times we forget when we have to find the other variable. So it's easier just to make sure that when you solve the algebra problem, you just have the answer. So now I get 4D minus 24 plus 3D equals 74. 4 and 3 is 7, so 7D minus 24 equals 74. Whoops. And then add 24 to both sides, so 7D is 98. And then divide each side by 7, and D is now 14. All right, so that should be our last problem. Let's make sure. So we went over linear functions, so slope, how to find slope in standard form, and how the types of solutions to a linear equation. Quadratic functions, which we have different ways to solve a quadratic. We can use the discriminant, and we also need to know the different forms and what their constants and coefficients tell us. Then linear systems, we have to know the types of linear systems we could have when we have one, none, or infinite number of solutions. And we also need to know how to solve linear systems using the elimination or substitution method. All right, so that brings video 2 to a close. I hope that was helpful. Check out the other videos if you want to know, going over all the other parts of the one sheet. And as always, please subscribe to the channel. Check out our other videos. Check out our Instagram, TikTok, and Facebook with other videos related to SAT, and even I have some BC and AB calculus stuff up there too. All right, see you later.